Hey, hello y'all. I'm trying to resolve a problem on Prism. We'll be right back. Okay,
3, 2, 1. liftoff of the Falcon 9.
Vehicles pitching downrange.
Stage 1 prop is nominal. Stage 1 entry startup. Stage 1 is transonic. Stage 1 landing range startup. Stage 1 landing leg deploying.
Falcon 9 has landed.
Hello y'all, this is Nectar Space C. Welcome to my channel. Today is Starlink 8-5, this is gonna start a new group, which is the 8 section for another Starlink batch, which the 6th group has just ended at Starlink 6-60. This is the newest and improved version. I'm going to get into the mission details right here. So, today's launch is Starlink Group 8-5. The launch time is Tuesday, June 4th, 2024 at 9:16 p.m. CDT. This is a Falcon 9 Block 5. The booster is B-1067 on its 20th flight, landing on, just read the instructions, on its 30th, for the booster, it's 33rd day turnaround for the booster, and this will be overall the 327 Falcon recovery attempt. Starlink Group 8-5 is SpaceX's launch of a batch of Starlink V2 mini satellites for their second generation high-speed low Earth orbit internet satellite constellation. There's 20 payloads and they're going to low Earth orbit. This will be launching from Slick 40, Cape Canaveral Space Force Station, Florida, USA. This will be the 109th orbital launch attempt of 2024. Dang, I'm stuttering. This of 2024, the 358th mission for SpaceX. This will be the 58th mission for SpaceX of this year, but the 358th total launches for SpaceX. This would be the 344th mission of a Falcon 9 overall, and the 58th mission of a Falcon 9 of this year. This booster previously supported Sirius 22, Crew 3, Turksat 5B, Crew 4, Sirius 25, Starlink Group 4-34, Hotbird 13G, O3BM Power 1 and 2, Starlink 5-2, Starlink 5-5, Starlink 5-9, and Satra, Starlink Group 6-10, Starlink Group 6-22, Starlink Group 6-29, Starlink Group 6-35, and HTS 113BT Maraputa 2, Starlink Group 6-45, Starlink Group 6-55, and today is its 20th flight, which is Starlink Group 8-5. That's all for the booster. Let's watch its first flight and see what what it looked like and what it did for its majestic first flight.
And weather remaining go as we are approaching the T-minus 1 minute mark when Dragon will transition to internal power.
Falcon 9's in startup. Dragon is in countdown. LD, go for launch.
The launch director. Launch director pulled
Stage
go
2,
for
press
launch.
flight.
So with that, all systems are currently go for just over T-minus 30 seconds to liftoff.
T-minus 30 seconds.
And at T0, the rocket will be released from the hold down clamps at the pad. And as I mentioned earlier, that strong back right next to the rocket will retract the rest of the way, clearing the way for liftoff.
Stage 1, press for flight.
T-minus 15 seconds.
Falcon 9 is configured for flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff.
And liftoff of the 22nd SpaceX cargo resupply mission, bringing new solar arrays to the International Space Station.
Stage 1, propulsion is nominal.
We're at T-plus 40 seconds into flight. Awesome shot looking
Power and telemetry nominal.
the Cape, where Falcon 9 has launched. We're coming up on the next major milestone. That's the point of maximum aerodynamic pressure. That's when the stresses on the vehicle will be the highest.
Execute.
So in preparation for maximum aerodynamic pressure, we throttled down those Merlin 1D engines. Now that we're through that point, we'll throttle back up and continue on to the next of our sequence of events. We have several happening in rapid succession. That'll be main engine cutoff, followed by a stage separation. Then we'll have a first stage flip maneuver, second engine start, number 1, and then a boost back burn on the first stage. Now, main engine cutoff, or MECO, that's where all 9 of the Merlin 1D engines on the first stage will shut down. That's followed shortly after by stage separation, when both the first and second stages will separate. From there, the first stage will flip to prepare itself for entry. A few seconds later, the Merlin vacuum engine on the second stage will ignite to boost the Dragon into a low Earth orbit. That's called SES-1. And then finally, on the first stage, we'll have boost back burn start to slow down the first stage in preparation for re-entry. So again, those 5 events: MECO, stage separation, first stage flip maneuver, second engine start, and then the boost back burn, all coming up just in under 10 seconds from now.
And MECO.
Stage separation confirmed.
MVAC ignition.
Stage 1 boost back startup.
So successful Merlin vacuum engine startup. First stage has begun its boost back burn. That burn expected to last about 30 or so seconds. Here's a shot of the second stage Merlin vacuum nozzle. You can see it starting to heat up as we begin this burn. The second stage will continue to burn here for several minutes until about the T+8 minute mark.
Stage 1 boost back shutdown.
If you're just joining us, welcome. You're watching a live webcast for the 22nd commercial resupply mission to the International Space Station for NASA. This is SpaceX's 17th launch of the year, and we are flying a cargo configuration of our new Dragon spacecraft. On the right-hand side of your screen is the second stage, which is carrying the Dragon spacecraft into orbit. On the left-hand side of your screen, you can see Falcon 9's first stage with the grid fins extending. It just completed its boost back burn and is making its way back to our drone ship. Now, the rocket has to do more than just go up. It has to go sideways really fast. At liftoff, gravity is pulling straight down on the rocket, but as we ascend, we tilt the engines. That's called gimbaling, and that begins to turn the rocket horizontally. We're still going up, but we're also heading horizontally away from the launch pad. That maneuver is called a gravity turn. The rocket typically needs to go about 7.5 kilometers per second, or about 17,500 miles an hour, to avoid being pulled back down to Earth and to get into orbit. So that's what the second stage is doing right now. Now, the first stage, in order to make its way back to our drone ship, named, of course, I Still Love You, it has two more burns to do. First is an entry burn. It'll ignite 3 of its Merlin 1 engines. That'll help to slow it down as it re-enters the Earth's atmosphere. And then the next activity will happen much closer to the drone ship. That is the landing burn. Will ignite just the single center Merlin engine to bring the vehicle's speed rapidly down to 0. You can see the grid fins that are extended on the left-hand side of your screen. We use those for atmospheric control. They help steer the Falcon 9 to make sure we make our way back to that drone ship as we get into the thicker parts of the Earth's atmosphere. And you'll occasionally see periodic bursts of a white gas like that. That's our attitude control system, giving us little corrections to our attitude. So next major event coming up here for the first stage is entry burn. 3 of the Merlin 1D engines will ignite. Second stage burn continuing to look nominal. Second stage has a little ways to go. It won't be done with this burn until about the T+8 minute mark.
Stage 1 FTS is saved.
Trajectory nominal.
Stage 1 entry burn startup.
So with that, 3 Merlin 1D engines on the first stage igniting to reduce the vehicle's velocity. You can see that on the bottom left corner of your screen. This burn expected to last about 20 seconds. So from here, the grid fins will continue to take the first stage towards our drone ship stationed out in the Atlantic Ocean. At this point, T+6.5 minutes into flight, second stage is making its way to the initial orbit to drop off the Cargo Dragon spacecraft. And if you're just joining us, welcome. On your screen is a live view of Falcon 9's first stage on the left, the second stage on the right. We had an on-time liftoff at 1:29 p.m. Eastern Time. Nominal ascent so far. Talking a little bit more about
Stage 1 transonic.
Talking a little bit more about the first stage. So the next major event coming up is that landing burn. Landing burn is what will bring the vehicle speed rapidly down to 0. Amazing shots of the first stage during re-entry. Once we get closer to the drone ship, we will deploy our 4 symmetric landing legs around the base of the first stage for hopefully a nice soft touchdown on that drone ship. You can see a shot of that on the right-hand side of your screen.
Stage 1 landing leg deploy.
Picture perfect landing of that Falcon 9 for the
Stage
first
one
stage.
landing confirmed.
First landing for this first stage. 86 successful recovery overall for SpaceX. Fantastic.
Those some amazing shots. Alright, I'm gonna start getting everything back up for you. Alright, I'm gonna read this off of SpaceX's website. Alright. So, SpaceX, at 38 minutes, SpaceX launch director verifies go for propellant loading. At 35 minutes, RP1 loading begins. At 35 minutes also, liquid oxygen on the first stage begins. At 16 minutes before the launch, the second stage LOX loading begins. At T-minus 7 minutes, Falcon 9 begins engine chill before launch. At 1 minute, flight computers found pre-launch checkouts and the vehicle pressurizes before launch. At 45 seconds, SpaceX gives the verified go for launch. At 3 seconds, engine ignition sequence happens. And at 0 seconds, Falcon 9 lifts off. At 1 minute 10 seconds, max Q happens. At 2 minutes 25 seconds, first stage engine cuts off. At 2 minutes 28 seconds, the first and second stage separate. At 2 minutes 35 seconds, second stage ignition happens. At 2 minutes 58 seconds, deployment happens. At 6 minutes 10 seconds, entry burn begins. At 6 minutes 36 seconds, first stage entry burn. And at 8 minutes, land burn begins. At 8 minutes 24 seconds, the first stage lands. At 8 minutes 39 seconds, the second stage engine cuts off. And oh! Whoa! Whoa, 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 whoa. Okay. Since there's a little bit, less payloads, they're gonna, okay, at 42 minutes and 44 seconds, the second stage engine starts. At 42 minutes and 46 seconds, second stage engine cuts off. And at 51 minutes and 38 seconds, the Starlink satellites deploy. So, for the first stage is launch, ascent, stage separation, flip maneuver, grid fence deploy, entry burn, aerodynamic guidance, vertical landing, autonomous drone ship landing. For the second stage is launch, ascent, stage separation, fairing separation, and payload separation. Those are the events in that order. Alright. Let's do some simulations in Juno New Origins. Alright, here's the first stage. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff. Falcon 9. Vehicle switching damage. No program. Miko, manage your cutoff. Stage separation. And back in the fairing separation. Stage 1 Griffins deploy. Stage 1, okay, right. Stage 1 issue burn startup. Stage 1 entry burn shutdown. Stage 1 transonic. Stage 1 landing. Stage 1 landing deployed. Touchdown. Alright. That'll end it for that. Sorry, my bad. Here is the area. The weather is a little bit cloudy. There's some occasional rain, storm. You see right there? Nothing real bad. I mostly would be expecting clouds as to our weather violation. Alright, so, two different events happened of focusing on this mission. The first one was 5 hours before now, targeting tonight for a Starlink launch of 20 Starlink satellites to low Earth orbit, including 13 direct-to-cell capabilities. All systems are looking good. Weather is 95% favorable, and propellant load is about to begin for tonight's launch of 20 Starlink satellites from Florida. Also, we're T-minus 2 days, about to be T-minus 24 hours until Starship Flight 4. I'll be streaming it about 2 hours or less until the launch. I definitely will be streaming it in 2 days. The day after tomorrow. Be ready. I'll explain more of this when Starliner's launching. But be ready for lots of stuff to happen, because it's gonna be very, very New update. Okay, I'm gonna set this in ground. I'm gonna be getting up at 5:30 a.m. in the morning. I'll be streaming 1 hour and 15 minutes before launch, just like every other launch. So currently targeting June 6th on Thursday. Godspeed. I'm preparing. I got everything ready. And then we'll watch propellant load and let it go and send it. I'm drunk. Oh my gosh. Okay, so Starship Flight 4 is already pumping me up. We are just ready for it. Be ready. They're already fixing up heat. Hey, this will be the third final launch, final SpaceX, or this will be the final SpaceX launch until Starship launches. Maybe, but time will tell. Godspeed, just IFT4. I'll be preparing, and you'll be seeing me on June 6th, like IFT2, make historical, groundbreaking history during June 6th. First time, hopefully, Starship re-enters nominally.
Tanks are pressing for strong back retract. Strong back retract has started. Stage 1 LOX load is complete. Stage 2 LOX load is complete. Ground gas closeouts has started. Falcon 9 is in startup.
Launch director, go for launch.
T-minus 30 seconds. T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff. Go Falcon, go Starlink.
Vehicle is pitching downrange.
Stage 1, chamber pressure is nominal.
Mach 1. Maximum dynamic pressure.
MVAC chill.
Nominal trajectory.
MECO.
Stage separation confirmed.
MVAC ignition.
Fairing separation confirmed.
Stage 1, entry burn startup.
Stage 1 FTS is saved.
Entry burn shut down. Nominal trajectory. Stage 1 is transonic. Stage 1 landing burn. Stage 2 is in terminal guidance. Stage 1 landing leg deploy.
Stage 2 FTS is saved.
Stage 1 landing confirmed.
MVAC shut down.
Nominal orbit insertion.
Alright, that was a beautiful mission on B-1067's 20th flight, 20th landing. Looks like boosters that are hitting 20 flights is getting pretty consecutive. Pretty fast now. Alright. The next launch, is called PREFIRE Nice. Um, we have been down this lane before. Um, Alright, so, mission details for this launch. Alright, wait, let me fix this. Okay. Alright, so this is PREFIRE 9, so launch time for this is Tuesday, June 4th. Let me, at 10:15 p.m. CDT. This is an Electron / Carry. This is going to be launching from Rocket Lab, LC-1B, Maha, Peninsula, New Zealand. This will be 110th orbital launch attempt of 2024, the 49th mission of Rocket Lab, the 7th mission of Rocket Lab of 2024, and the 49th mission of Electron of of its history, and the 7th launch of Electron this month. This year. So, yep, that's all you need to know about this launch. Alright, let's simulate this. Um, or actually, yeah, we'll do it. We'll simulate it. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2. Rutherford engines ignition. And liftoff. Rutherford cutoff. State separation confirmed. And Rutherford vac ignition. Coming up on fairing separation. Fairing separation confirmed. And about a couple minutes later, we have engine cutoff. Now it'll be a nominal orbital insertion. And then payload separation, ending the mission. Basically, the weather is looking basically the same as yesterday, which that's. Wait, let me see. Let me see what caused the abort. Um, Twitter. All right, I'm looking. Okay, rocket led an igniter test on Electron. Okay, the launch attempt was scrubbed due to launch attempt due to an out of family sensor reading. So, it's not the weather that caused it. That's good. So I'm going to show you the weather real quick. It's going to be the same as yesterday. I mean, 2 days ago. It's going to be the same as the last launch. It's pretty cloudy, so that's on the launch time. But yeah, that's fine. It's going to do good though. Alright. Alright, whew. Oh, it's pretty stormy here. weather for this launch is 80% go.
Hello and welcome to the launch webcast for our 49th Electron mission, set to launch from Pad B at Rocket Lab Launch Complex 1 in New Zealand in just under 19 minutes from now. Today we'll be launching the second of two launches for NASA's Climate Science PREFIRE mission after standing down a couple of days ago due to out-of-bounds LOX temperatures. Thanks for joining us. My name is Muriel Baker and I'll be taking you through today's countdown to liftoff for the PREFIRE and ICE mission, currently set for launch today at 3:15 p.m. local time or 03:15 UTC. Now, PREFIRE and ICE is the second of two back-to-back launches on Electron to deliver NASA's satellites to orbit for the PREFIRE mission. PREFIRE stands for Polar Radiant Energy in the Far Infrared Experiment, and it's a mission designed to measure heat loss from the Arctic and Antarctica to help improve climate and ice loss models that better predict Earth's ice, sea level, and weather changes. The first satellite in the PREFIRE mission was deployed by Electron to its 525-kilometre orbit 11 days ago. After today's second launch and deployment, the two PREFIRE satellites will spend the next 10 months crisscrossing Earth's coldest regions to collect their data. And once they're operating, PREFIRE will make the first full spectral measurements of far infrared radiation, revealing the full spectrum of Arctic radiant energy. Now, those measurements will then be used in climate and ice models to help better predict Earth's sea ice loss, ice sheet melt, and sea level rise. PREFIRE is focused on the Arctic and Antarctica because these polar regions have a big influence on the Earth's temperature. Excess heat escapes from there to space, and the difference between how much heat is released versus how much heat is received from the sun in the tropics is a key influence on the planet's temperature. Better understanding this process and what it means for Earth's future climate is what the PREFIRE mission is all about. Here's NASA to explain more.
The Arctic is warming 3 times faster than anywhere else on Earth.
This is a huge problem, in part because that is enhancing melt of the ice sheet. It's leading to enhanced melt of sea ice.
All of the coastal communities around the world are now seeing sea level rise around them and experiencing increased flooding.
It will impact the future generations. They're going to inherit a planet that's going to be many degrees warmer than what we are today.
We need to have better predictions of how sea level will change, how the weather around the planet is going to change. The only way we're going to do that is to understand how the polar regions are responding to climate change.
We have this considerable knowledge gap in our understanding of Arctic climate.
PREFIRE is going to fill this important gap.
PREFIRE, polar
radiant
energy
in the far
infrared
experiment.
So Earth's temperature is set by a balance between the amount of energy the Earth receives from the sun and the amount of energy that it emits back to space.
Most of the energy that is radiated to space from our polar regions is far infrared energy, and we have no modern satellite observations of this incredibly important energy spectrum. PREFIRE will be deploying 2 CubeSats. Over the course of a year, they're going to be measuring the far infrared energy for the very first time that is leaving the top of our atmosphere.
Each of our PREFIRE CubeSats carry something called a thermal infrared spectrometer that looks down at the Earth and gathers energy being emitted from the planet at different wavelengths.
Just imagine a rainbow. When you see a rainbow, you see the different colors in the rainbow, and what happens is light gets dispersed. Similarly, we see the different wavelengths split up, and you can measure each of these wavelengths, and that's what the spectrometer does. It spectrally separates the radiation into different wavelengths.
These wavelengths were going to give us really important information about how the surface is changing in the polar regions, whether that's going from an ice-covered surface to a melted surface, or whether it's going from sea ice to open ocean.
The 2 satellites are going to be orbiting in a polar orbit around the Earth. The first satellite comes along and measures the scene over the poles, and then a few hours later we have the second one come along in a different orbit and measure the same scene, so you understand the impact of how the energy changes in those few hours.
It's really important that we understand how much energy is being emitted by the polar regions, because that defines how cold the polar regions get. And that temperature difference between the warm tropics and the cold polar regions is actually what drives the entire weather system around the planet.
What we want to do with PREFIRE is we want to take these new observations that have never been made before, and we want to improve our understanding of the climate system and improve our understanding of how climate is going to be changing.
Understanding how the sea level rises and how the ice melts is going to help us understand weather events, and that's going to have direct impact on our farmers and agriculture.
There's a real urgency to getting this information now. Things are changing so quickly in the Arctic that we may only have 5 to 10 years to respond to those changes and help protect the property and lives that may be affected by that.
Launching the PREFIRE mission for NASA represents a bit of a full circle moment for Electron, because it was around this time last year that Electron launched a constellation of small satellites for NASA for a mission called TROPICS that was focused on the regions of Earth surrounding the equator, helping weather researchers understand more about the environmental factors that contribute to hurricanes there. So, from the tropics to the poles, Electron has been behind NASA's small satellite missions that teach us more about our environment and the world around us. Now, shortly, today's operators will be polled for their launch readiness in the final go, no-go poll run by our launch director, Julia Wembacher. That status check begins at the T-minus 12-minute mark to liftoff and goes through each operator on console in our Mission Control Center and in our Range Control Center at the launch site. We're coming up to the poll now, set to begin in just a few seconds.
And to all operators, LDN mission code, we're proceeding now with the go, no-go sequence. Stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Recon.
Recon's go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
Net is go.
RF.
RF is go.
Copy, thank you. MM.
MM is go.
And LDSUP.
LDSUP is go.
The go, no-go sequence is complete. We are currently T-minus 11 minutes and 9 seconds and counting. We are go for a terminal count auto sequence at T-minus 10 minutes. From this time, the 3-watt hold procedure is in effect.
Greens across the board there from our launch operators during that go, no-go poll, with the team moving ahead with all remaining launch operations ahead of liftoff. Our launch time remains set for 3:15 p.m. local time or 03:15 UTC in approximately 10 minutes 39 seconds. While all eyes are on Electron's launch today from the Southern Hemisphere back in the United States, we have a team working steadily on a mission of another kind for our new big rocket, Neutron. We have the first of our new Archimedes rocket engines on the test stand at the Stennis Space Center in Mississippi, being prepared for its first hot fire in the coming weeks. Now, we'll have 9 of these engines powering the first stage of Neutron to produce a total combined liftoff capacity of 1,485,000 pounds of thrust. In fact, one Archimedes on its own produces the equivalent of about 3 entire Electron rockets. Now, since the engine arrived in Stennis a few weeks ago, the team there has completed numerous checkouts and activations of the test site's infrastructure and its supporting systems. The site's flame stack has been burning bright in preparation, and we can't wait to see the engine burning bright too, with its blue flame mix of liquid oxygen and methane. Here's more from the team at Stennis as they prepare for Archimedes' first hot fire.
I'm Nicky Rains. I'm the manager for Rocket Lab's facility here at Stennis Space Center. We just installed the Archimedes engine for the first time on the test facility. So we've got engine system integration. There's piping, valving, wiring going on. That's being worked real time with software. Back in our control room, the human-machine interface, HMI, that we use to control things. Those things are in the final preps and final checkouts. We're ready now to push the engine through final commissioning and ready for hot fire. Rocket Lab came into NASA Stennis with the lease for the A3 stand. It was a historic stand built for the Constellation program in the late 2000s. We've been able to utilize hardware. We've taken tanks, we've taken valves, existing piping, whole existing systems for gaseous nitrogen, and be able to repurpose those systems and put them to work for what we need. It lets us go faster, it lets us save money, and it lets us get that initial operational capability Archimedes needs. It's great for Rocket Lab as a commercial company to be partnered here with NASA. We get to use this facility, so we're taking advantage of the existing hardware and being able to repurpose parts of the stand, but we also have a community of support around us. There's contractors here who know how to build rocket test stands, welding, piping, major big concrete and steel structures. There's people who know how to make rocket operations work. So we got that community of people here to support us, and it's a great place to be for a commercial company to be in the middle of this with all that support and the ability to run our operation. My sincere appreciation for the team that we have here at Stennis, the team globally with Rocket Lab. We've had support from New Zealand and Long Beach and from Wallop. So they've come together here. We put a ton of work in here in the last year, and to see it all come together should be exciting for all of us. The team deserves a huge congratulations from everybody involved that have gotten us this far.
If you want to get in on the next round of engine hot fires, it is not too late to join the Neutron team in Mississippi and California. We have open roles in manufacturing, design, engine development, and more across several states. You should check out rocketlabusa.com for your options. T-minus 6 minutes, 27 seconds to launch. Let's take a look at the Electron rocket for today's mission. Electron is a 3-stage liquid-fueled launch vehicle designed specifically for small satellite missions. And over its 48 missions to date, Electron has deployed more than 180 satellites across various low Earth orbits for science, commercial, and national security missions, including a mission all the way to the moon for NASA. Now, Electron has a lift capacity of just over 300 kilograms to LEO. The rocket stands 18 meters or 59 feet tall, and once fully fueled, weighs 13,000 kilograms or more than 28,000 pounds. The rocket's black look comes from the carbon composite material that it's made of. We use carbon composite across Electron's external structure, as well as throughout its internal systems and propellant tanks, which helps to keep Electron as lightweight as possible. Where the rocket looks white is where you're seeing ice form on the outside from the freezing cold temperatures of the liquid oxygen propellant that's being loaded into Electron's tanks. We use a mix of liquid oxygen and kerosene as the propellants for Electron's Rutherford engines. We have 9 of those at the bottom of the first stage and a 10th Rutherford engine that's attached to the second stage. The engines are identical across both stages except for a large expansion nozzle on the second stage Rutherford engine that supports its performance in the vacuum conditions of space. Now, all of our Rutherford engines are 3D printed and battery powered, which makes them unique as far as rocket engines go. Once Electron reaches space, though, it separates its first and second stages to continue the mission to orbit, and then repeats this process again between its second and third stage. This third stage is called the kick stage, and it's what the PREFIRE satellite is attached to all the way through to payload deployment. The kick stage has its own little engine called the Curie, which we use to precisely deploy satellites exactly where they need to go in space. The kick stage will be released at the perigee of this mission's trajectory, which is the lowest part of the kick stage's path around Earth. It's set on an elliptical orbit first, so to course correct to a circular orbit, we wait until the kick stage reaches the other side of the planet and the trajectory's apogee, which is its highest point, close to that 525-kilometer target. Now, once here, the Curie engine will light up to set a circular course around Earth before a few moments later releasing the payload to space and ending the mission for Electron. Now, all of that is coming up shortly now that we are just 3 minutes and 45 seconds until liftoff of PREFIRE and DICE. It's time to send it over to Mission Control to take it from here for the remainder of the count, and I'll be back with you shortly after liftoff. Go NASA, go PREFIRE, and go Electron.
And to all operators, LD and mission code. From now on, there should be no red flags on your critical LCCs. Beacon LD mission code.
LD beacon.
Please lock the auto sequence and confirm.
Auto sequence is locked.
Beacon, please confirm all expected primary flight computer ASCIIs are green.
That's confirmed.
We go for an auto sequence start at T-minus 2 minutes. LDs go for launch.
Vehicle is fully on internal power. AFTSs are green and enabled for flight.
LOX load is complete. System is in recirculation. Anti-geysering is disabled.
Stage 1 and Stage 2 tanks are pressed for flight.
High flow engine purge enabled.
We are T-minus 20 seconds and counting. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Lift off.
Beginning pitch over. Stage 1 propulsion.
There goes our 49th Electron rocket soaring off the pad at Launch Complex 1 and on its way to space for NASA. We are now 39 seconds into the mission and our first mission milestone is coming up called Max Q. This is when Electron reaches the maximum amount of pressure that will work against the rocket as it powers its way through the atmosphere. We should hear a call out from Mission Control soon that Electron has made it through that structural test.
High voltage battery discharge nominal.
Cleared Max Q.
That's Electron smoothly through Max Q as the mission continues. We are now at 1 minute and 18 seconds into the mission as Electron passes more than 18 kilometers in altitude at more than 2,300 kilometers an hour. Up next are a familiar set of actions that Electron performs to continue the mission. The first up will be MECO, or main engine cutoff, when all 9 Rutherford engines on the first stage throttle back before shutting down. After that is stage separation, followed by the engine startup on Electron's second stage to carry onto orbit with NASA's PREFIRE satellite. Standing by now to listen out for Mission Control to check off those milestones.
AOS Chathams.
Stage 1 propulsion is holding nominal. Stand by for MECO in roughly 30 seconds. "15 seconds till staging."
Entered burnout detect mode.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition confirmed.
That was MECO, stage separation and second stage engine start for Electron. The second stage Rutherford engine is glowing hot and bright as it carries onto orbit, now more than 100 kilometers above Earth and moving at more than 8,000 kilometers an hour. Now this engine is identical to the sea-level Rutherford engines used on Electron's first stage, with that exception of a larger expansion nozzle that allows for improved performance. Next up is fairing jettison of the rocket's nose cone. And the fairing is what protects the satellite on Electron through flight. But once Electron is ready to be rid of the nose cone, each half of the fairing is designed to rotate on a hinge away from the payload in a safe separation motion. And that action is due now in just a few moments, so let's listen in.
Fairing jettison confirmed.
And there they went. Electron's fairing halves have split and fallen away from the rocket as planned. Now that nose cone is ejected once we reach space and we don't need its protection anymore for the NASA PREFIRE satellite that is on board. We're heading to a 525-kilometre orbit for this mission, but stage 2 will only take us to just over 200 kilometres to our perigee, where we'll separate the kick stage that has the PREFIRE satellite. So another 100 or so kilometres to go for Electron's second stage. We are approaching the next mark in the launch for Electron's second stage, an action that you'll only come across with our rocket called the battery hot swap. The Rutherford rocket engine powering the second stage uses batteries as the power supply for its propellant pumps. Now, those have been running for some time now, so the battery's power levels are running low. And to prevent an engine stall, we swap out those dying batteries with a fresh pack that will keep the engine running its full duration. Now, those old battery packs are ejected once they're done, which you can sometimes see on your screen as they fall away. So watch out for those just after the T+6 minute mark into the mission.
Throttling down.
Battery jettison confirmed.
And that is battery hot swap confirmed for the second stage Rutherford engine, called out by the operator in mission control, in which we saw on our screen just moments ago. Now, with that clean swap, the Rutherford is continuing nominally along its journey, maintaining its current trajectory towards that perigee and moving along at more than 15,000 kilometres an hour. We have a couple more minutes to go with Electron's second stage as we approach its final set of actions, with engine shutdown and stage separation expected soon after we tick over 9 minutes into the mission. Seven minutes and 10 seconds into the mission, well over 17,000 kilometres an hour now, and things are looking nominal for that second stage engine burn. The next milestone for this mission will be the second engine cutoff on that second stage, which we're coming up to in just a few moments.
High voltage battery discharge holding nominal.
Stage 2 propulsion is holding nominal.
It's now 8 minutes, 16 seconds into the mission, which means we are coming up on the engine shutdown for Electron's second stage, to be followed shortly afterward by stage separation of the kick stage that is carrying NASA's PREFIRE satellite. The process is practically the same as the first stage engine shutdown and stage separation that Electron performed earlier in the launch. We'll know that it's been successful when we see that red-hot engine nozzle on the screen start to turn cold with that successful engine shutdown. We're waiting, though, on the call-out from Mission Control for confirmation of those actions.
Guidance is in terminal, 20 seconds remaining.
SECO confirmed.
Stage 3 separation confirmed. Nominal transfer orbit achieved.
Successful engine shutdown and a clean stage separation for Electron. The kick stage has been released at its perigee with its attached PREFIRE satellite ready to join the first PREFIRE satellite deployed to space just last week. Now, with the kick stage released onto an elliptical orbit first, it now has to complete its first set of maneuvers to correct to a circular orbit. This involves an engine startup in about 40 minutes once the kick stage completes its first half orbit of Earth. We'll take a break in the webcast now, but come back live for that engine startup, as well as the final milestone for this mission, payload deployment for NASA's PREFIRE satellite. We'll see you back here soon.